Welcome to Math TV with Professor V. In this video, we're going to look at various examples of how to find limits of trigonometric functions. So before we get started working on examples, we're going to need to use the following two limit formulas. First one is that the limit as theta approaches 0 of sine theta over theta is equal to 1. And the important thing to remember about this formula is that the argument, the angle, so sine of theta, has to match the expression in the opposite side of the fraction, and that argument needs to approach 0. Theta has to go to 0. Okay, alternatively, we do have that the limit as theta approaches 0 of theta over sine theta is equal to 1 also, because that's just finding the limit of the reciprocal, and the reciprocal of 1 is still 1, okay? That's the first limit formula. Second one that we use is that the limit as theta approaches 0 of cosine theta minus 1 over theta is equal to 0. And in this case, no, the limit of the reciprocal will not have the same value because the reciprocal of 0 is not 0. But there is one variation that we can use, and that is the limit as theta approaches 0 of 1 minus cosine theta over theta is also equal to 0. Because think about it, that's just reversing the order of subtraction in the numerator, which changes the sign on the limit, but negative 0 is still 0, okay? So those are the only two variations. And then I'm going to work through several examples right now. We will not be using L'Hopital's rule for any of these exercises. That's something that you learn typically later in the semester in calculus. And these trigonometric limits and formulas are studied at the beginning of the course. So for my classes, I don't let my students use L'Hopital's rule until we've learned it later on, not for these problems. Here we go. First example. The directions are pretty much all the same, so we'll just say find the limit. Short and sweet. Number 1, let's find the limit as x approaches 0 of sine of 5x over 3x. Okay, so look at our limit formula. Things are looking kind of similar. It's just we have a problem because notice I have sine of 5x, which does not match the expression in the denominator. There's a 3x, okay? So we're just gonna play around and manipulate things so that we can use our limit formula. So instead of a 3x in the denominator, what do you wish was there? Don't you wish that 3 was a 5 instead? Me too. So just make it happen. Don't sit around feeling sorry for yourself. I'm just going to put a 5 in the denominator. And then to make sure that I'm keeping things equivalent to where they started, I'm going to have to multiply by 5 in the numerator as well. Okay, so now watch how I'm going to regroup everything. We have the limit as x approaches 0 of sine of 5x over, I'm going to group this 5 with the x in the denominator of sine 5x, see that? Times, and then leave that 5 in the numerator, and then now the 3 is in the denominator. So basically, this 3 and 5 did a little switcheroo, okay? But I'm super happy since now I have sine of 5x over 5x, which means I can use my limit formula. So this expression is going to approach 1. Woohoo! So our final result is that we have 1 times 5/3, which is 5/3. Okay, good. How are we feeling? Let's take things up a level, make it a little more interesting. So here we have the limit as t approaches 0 of tangent of 6t over sine of 2t. Okay, my advice to you is when you're given any other trigonometric function, like tangent, secant, cosecant, cotangent, most of the time it's helpful to rewrite it in terms of sines and cosines. Okay, so I'm going to do that first. I'm going to rewrite this now as the limit as t approaches 0. Instead of tangent of 6t, I'm going to write it as sine of 6t over cosine of 6t. And don't worry, I didn't forget about the sine 2t. It's over here, times 1 over sine 2t. Okay? Good, good, good. Now I want you to walk through the same line of reasoning that I used for the previous example, all right, as we figure out what to multiply by so we can use our limit formulas. So first focus on sine 6t, okay? Sine 6t. Oh my goodness, what do we wish was in the denominator? Not that cosine 6t. I wish that there was another 6t down there. So I'm going to add it in. And then I have to multiply by 6t over 1. That way I'm just multiplying by 1, right? I'm not doing anything illegal. All right, times, I'm just going to leave 1 over cosine 6t over here alone, minding its own business. Here's that cosine 6t. And then we have times, okay, look here. Instead of a 1, what do you wish was in the numerator of that sine 2t? Have you figured out what you would like to have up there? I would love it if we had a 2t, wouldn't you? And then if I'm adding a 2t in the numerator, I better add one in the denominator. Now there's more than one way to go about evaluating these limits and manipulating. Okay, I kind of really expanded and took my time so you guys can see the thought process. All right, so let's think about what's going on here. I'm ready to roll because sine of 6t over 6t, that will approach 1 as t goes to 0. Same thing for the 2t over sine of 2t, that's going to approach 1. Now don't be nervous over here. We have 1 over cosine of 6t. T is going to 0. 6 times 0 is still 0, right? And what's cosine of 0? Cosine of 0 is 1. So this term is also approaching 1. Okay, anything else you notice? I'm observing the fact that I can cancel out a t in the numerator with a t in the denominator. And all I'm left with now are 6 and 2 from those terms. No more variables, okay? So after I take the limit of everything, I'm going to have 1 times 6 times 1 times 1 times a half, which is 3. All right, very good. Now I would need to see all of this work, right, for a full credit result on an exam. Don't do some weird mumbo jumbo like 6 divided by 2 is 3, okay? You'll get no points for that, garbaggio. Good. Let's look at some more examples. We've got here, number 3, the limit as x approaches 0, sine of 3x over 5x cubed minus 4x. Okay. Now let's think about things here. I haven't dealt with x cubed before. We only have x to the first, or you could have something like sine of x squared over x squared. That would be fine. You could say that that's going to 1. However, when we have these two terms in the denominator, that's not very helpful. So what I'm going to do is see if I can factor something out from both of them, and I sure can. I can take out an x from both of those terms down there, so let's go ahead and do that. So we've got the limit as x approaches 0 of sine of 3x over x times 5x squared minus 4. Good? Okay, now let's break things up because I want to use our limit formula. So I'm going to group these two parts of my limit together. So now I have the limit as x approaches 0, sine of 3x over, now I have only a little x. I wish that there was a 3 in front of it, right? So I'm going to add 1 in, and then I have to multiply by 3 over 1 in order to compensate. And then times, I just have 1 over 5x squared minus 4 left over, okay? Now let's see here. Can I evaluate the limit at this step? So as x approaches 0, sine of 3x over 3x, that's going to approach 1. 3 over 1 is just a constant, so that's 3. And then 1 over 5x squared minus 4. So x is going to 0. This term will approach negative 1 over 4. So yeah, we're done. Wow. It just took one little step of factoring and multiplying and dividing by 3. We've got 1 times 3 times negative 1 over 4. So this limit is negative 3/4. Okay, very good. How are you feeling so far? You feel professional, ready to take a test? Let me give you one to try on your own. What number was that? 3? Okay. You guys are going to do this one on your own. It's so similar to the one I just did, okay? Limit x approaches 0, sine of x times cosine of 4x over x plus x cosine of 5x. So pause the video, give yourself a minute, see if you can evaluate this limit, and then push play, watch me solve it. Okay, good. Did you do the problem on your own? I hope so. Here we go. Let's see. So we have limit x approaches 0. Did you factor out that x from the denominator? So then you have x times 1 plus cosine of 5x. And then you have sine of x cosine of 4x in the numerator, right? Good. And then from here, it's just a matter of regrouping everything. So we want to write this as the limit as x approaches 0. I'm going to write sine x over x times cosine of 4x over 1 plus cosine of 5x. Okay, so all I did was just regroup all the terms that are being multiplied. And then now we're ready to roll. So sine of x over x, that's going to approach 1. And then remember, x is going to 0. So cosine of 4 times 0, that's cosine of 0. That's approaching 1. So is this guy. So what we're left with is 1 times 1 over 1 plus 1. Yes? So that's 1 times a half, which is just 1/2. Beautiful. Did you like that one? Did you get it right? I hope so. Okay, let's look at another. Let's mix in some other trig functions. So we've got the limit, x approaches 0, 6x squared times cotangent of 3x times cosecant of 2x. Okay? What do you think we should do first? What did I say is a good tool to apply when you have cotangents, cosecants? You want to rewrite it in terms of sines and cosines. So we've got the limit as x approaches 0 of 6x squared times, now cotangent 3x, that's cosine 3x over sine 3x, times cosecant 2x is 1 over sine of 2x, okay? Good, good, good. And then watch this one. Oh my goodness, whoever wrote this problem sat there thinking about us, trying to make our life so nice. Here's a sine 3x. I wish there was a 3x in the numerator, don't you? And then here's sine of 2x. I wish that there was a 2x in the numerator. Well, we've got a 3x and a 2x just in disguise as 6x squared. So I'm going to break it up. I'm going to break it up like so. We've got the limit x approaches 0, I want you to think of this 6x squared as 3x times 2x. Is it not? It is. So this 3x, I'm going to write it over sine 3x. And then this 2x is going to go over sine 2x. So beautiful. 3x over sine 3x. Now don't forget there's times that little cosine 3x just hanging out minding his own business. And then 2x over sine 2x. Very nice. Now let's see, can we evaluate the limit? So as x approaches 0, 3x over sine 3x will approach 1. Cosine of 3x, where's that going? 3x is going to 0, cosine of 0 is 1. And then 2x over sine 2x, that's approaching 1. So what do we have for our final answer? 1 times 1 times 1, which is just 1. Good. Nice work. I think you guys are getting pretty professional at this point. So I'm going to give you some spicy ones. Here we go. That was number 5. Here's number 6. The limit as theta approaches 0 of sine theta over theta plus tan theta. Okay, so maybe you're thinking, ooh, let me rewrite everything in terms of sines and cosines. We can definitely do that. And then the other problem is, I'm so upset, this theta has a plus tan theta, right? Oh my goodness, if only there was no plus tan theta, we would be done. So we'll talk about what to do to fix things in just a second. But I'm going to write this now as the limit as theta approaches 0 of sine theta over theta plus sine theta over cosine theta. Okay, now maybe you would think, oh, let me clear out the fractions multiplied by cosine theta, but that's just going to make things messier. What I'm going to do is divide everything by theta. So I'm going to multiply the numerator and denominator by 1 over theta so that I can use my limit formula. So watch this. So now I have the limit as theta approaches 0. In the numerator, I have sine of theta over theta. Don't panic, it's okay that we have a fraction in the numerator. And then now when I distribute 1 over theta to theta in the denominator, that's just going to give me a 1. And when I distribute it to sine theta over cosine theta, watch how I'm going to write it. I'm going to write it as sine theta over theta times 1 over cosine theta. That way I'm ready to go and use my limit formula, yes? You guys, we're done. So sine of theta over theta, that will approach 1. This 1 is a constant. Okay, so that's staying 1. This sine of theta over theta, that's going to 1. What about 1 over cosine theta? You remember what cosine theta is? It's 0. Cosine of 0 is 1. So 1 over 1, this is just going to 1. Okay. That was a little bit sneaky, huh? So you've got 1 over 1 plus 1, which is 1/2. All right, very nice. Are you wondering about that other limit formula? We haven't used it, huh? It's feeling neglected. I know, we don't use that cosine one so much. I don't know what to say to you. Let's look at an example where you might be tempted to use it, but you actually shouldn't. So example number 7. I have for you the limit as theta approaches 0 of cosine theta minus 1 over 2 theta squared. So let's just move this down so we have room to concentrate. Okay, so you might be thinking, at long last, I can use that second limit formula. But no, I'm so sorry, because this is cosine theta minus 1 over, since we have 2 theta squared, you have an extra 1 over 2 theta, and then you're going to be stuck. because this is 0, this is going to 0, sure. But as theta approaches 0, remember, 1 over 2 theta, the denominator shrinking, that's going to be approaching infinity, negative infinity. So this is an indeterminate form. So this limit formula will not help us here. Oh no, what to do? Well, a lot of the time with trig functions, you want to try to bring in the Pythagorean identities when you're at a little bit of a sticky point and you feel like you're stuck. So since I see cosine theta minus 1 in the numerator, I want to multiply by the conjugate, which is cosine theta plus 1, and see if maybe I can rewrite things with sine. You know what I mean? No? Okay, you'll see in a second. So we've got the limit as theta approaches 0. Notice in the numerator we've got conjugate pairs. So when I multiply it all out, I'm going to have a difference of squares, cosine squared theta minus 1. The denominator I'm going to leave factored, okay? 99% of the time you want to leave your denominator factored. Now cosine squared theta minus 1, what is that equal to? It's negative sine squared theta. Did you catch the negative? Okay, remember, sine squared theta plus cosine squared theta equals 1. So if you had 1 minus cosine squared theta, yeah, that would be sine squared theta. But since we have cosine squared theta minus 1, that's going to be equal to a negative sine squared theta. Okay, watch those signs. How sad if you get a problem wrong because you were sloppy with the negatives. So we've got limit theta approaches 0, negative sine squared theta over 2 theta squared. Watch how I'm writing it. I'm already setting myself up for success. Times 1 over cosine theta plus 1. Okay? Very nice. Now let's see here. What am I going to do with this sine squared and theta squared? I can regroup it. Okay, I'm going to take all the constants outside. So I'm going to write this negative and 2 as just a negative 1/2 so I can focus on what's going on with the trig functions. Sine squared theta, that's just sine theta times sine theta. And theta squared is theta times theta. All right, you also could just have written this as sine of theta over theta squared. Same thing, right? Either way, both of those are going to 1. 1 times 1 is still 1. So that is taken care of. And then let's look at what's left over. I still have times 1 over cosine theta plus 1. So theta is going to 0. Cosine of 0 is 1. So this is 1 over 1 plus 1. That's going to 1/2. And then as we said, each of these approaches 1. And that negative 1/2 is just a constant. So in the end, what are we left with? Negative 1/2 times 1 times 1 times 1/2, which is negative 1 over 4. Okay, beautiful. How do you feel so far? Good? If you want an example using the other formula, I'll link a video here. And at the very end, I do an example using that second limit formula that I showed at the beginning of the video. Okay? One last one just for kicks. This was number 7. We're on to number 8. This is the limit as x approaches pi over 4. 1 minus tangent of x over sine of x minus cosine of x. Okay, so my advice, whenever you see a tan, a secant, a cotangent, a cosecant, rewrite it in terms of sines and cosines. So this is limit, x approaches pi over 4, 1 minus sine of x over cosine of x over sine of x minus cosine of x. Okay, I don't see any x's floating around where I could use my first limit formula for sine of x over x. And I don't really want to multiply by any conjugates. I don't think Pythagoreans are going to help me out here. So why don't we clear out that extra denominator that's in the numerator, the cosine x. So I'm going to multiply everything by cosine x, okay? And hopefully I can simplify things a bit. So limit x approaches pi over 4. When this cosine x distributes up here, I'm going to have cosine x minus, watch, cancels, right? So just sine x over, I'm just going to leave it and not distribute in the denominator, okay? Ooh, do you notice something? Something fun we can cancel? I have cosine x minus sine x and sine x minus cosine x in the denominator. So I can cancel those, but remember, I have to add a negative. Don't forget, a minus b is equal to negative b minus a. So if you have a minus b over b minus a, that reduces to negative 1. Okay, so don't forget to add that negative. And then now let's see what's going on. We've got the limit as x approaches pi over 4 for negative 1 over cosine of x. Oh my goodness, I can just use direct substitution to find the limit. I don't even have to bust out some fancy limit formula. Cosine of pi over 4 is rad 2 over 2, or 1 over rad 2 if you didn't rationalize it. So negative 1 over rad 2 is just going to be negative rad 2. Okay, so don't forget, sometimes it just takes a little cleaning up, and then you can go ahead and use direct substitution. You don't always have to use these limit formulas unless you encounter a situation where you're kind of stuck and it's appropriate. Okay? Feel free to give this video a thumbs up if you found it helpful and share it with your classmates. Let me know if there's any other sorts of topics that you would like to see videos or more examples on. I'll be happy to make them for you.